Only Jen, that might be a problem for. So I'm not in the lab today. I'm at the URock campus. It's the Rockland University College campus. I love that they call it URock. I think it's awesome. Other people in the system are like, URock? That's silly. I'm like, no, that's awesome. So I like that. And as you know, I think GIS rocks. So I think we're kindred spirits. So we're going to do the last part of problem set 2 today, the last thing you need to learn to do problem set 2. And that is about topology. Hopefully, we should be able to get through it all. I haven't done it in a while, although I did help somebody do it recently. So hopefully I'll remember all about how to do it. But it's, and I believe you did go over it in your lab about editing. I think it did have you do some topology editing there. So, and while we're at it, because of the way ArcGIS manages topology, we'll have to also create a geodatabase as part of this process. So we'll talk a little bit about, when we get there, we'll talk a little bit about geodatabases and what they're for and what they're good for and what they're not good for, so that you'll have, yes, like in the tutorial, exactly. And so that'll give us a chance to, just go over some geodatabase basics. But ArcGIS's topology tools are entirely embedded within the geodatabase infrastructure. So you can't use their topology tools without the geodatabase. So I don't use them very often unless I'm editing like this, and I haven't done a project like this in a while. So you'll probably see some heuristic problem solving as I go. But to begin, let's talk about topology. Does anybody remember from GIS 1 what topology is? What's the definition of topology? And while you're thinking that up, it's okay if you want to look it up. And, and the sort of dictionary definition, so that mountain terrain refers to topography. Feature classes that shared features. Yep, so you're on the right track there, Jen. Oh, incidentally, by the way, here's your attendance code, 6015. So the attendance code for today is 6015. So, so topology is, do I have it here? So topology is, yeah. Oh, here it is. Okay. Yeah, making sure they're all coincident. Good. So topology is, this is the definition of topology from the GIS dictionary. It's probably still there because it's a long-term piece of infrastructure. Yep. So there are various definitions of topology, and it does not want to, there we go, Control-C, Control-V, there. Oh, there it went, okay. Anyway, and I will make it so you can see me while I'm doing this. So topology is in its finest essence, it is a branch of geometry. So mostly mathematicians study it, and as an academic discipline. So it's a branch of geometry that deals with the properties of a figure that remain unchanged, even with the figure when it's bent or stretched or otherwise distorted. Here I have it written larger here. So it's the branch of geometry that deals with properties of a figure that remain unchanged even when the figure is bent or stretched or otherwise distorted. So let's think about what that means, and then we'll get to the other definitions. So if I have, let me actually even get a, I'm going to get a place to do a drawing. So if I have a bunch of, pieces of a drawing here, and they all share corners, right? Pretend they're stuck together perfectly. So these two figures are connected, and if I distort them, for instance, if I change their size like this, they remain connected in the same way. I could even warp them, right? So I could and rotate them. I can scooch them around. I can squinch. See, what happens if I do this? Yeah. So if I warp them into a new shape like this, their spatial relationship to one another, the way they touch each other, and in this case, slightly overlap, that does not change. And now think about what you've been doing over the last couple of weeks. You've been working on parcel data, right? So you took those parcel maps and you overlaid them, and then you created a polygon, and then you started cutting that polygon up into chunks, right? And that's how you got the parcels that you're creating for. I've just got to get it to there. We go. Now it matches up. So that's how you created those parcels. And so you could take those parcels and put them in a map and then change the projection. So you've been working in UTM Zone 19 North. You could change the projection to something else like Lambert conformal conic. And the shape of the parcels will change. But the ones that are snapped together will remain snapped together no matter how you warp or twist or change those shapes. They will still remain stuck together. Does that make sense, you guys? So that's a really, really important characteristic of excellent. That's a really important characteristic. And here I'm going to mute you, Jen. Feel free, Jen, to unmute yourself if you want to speak. But I want to make sure that, because if you are unmuted every time you make a noise, the screen switches to you. And we like you and everything, but so we want to make sure our parcel layer that we've created is topologically integrated. There are various ways that that's summarized. And so we want to preserve this characteristic. So if a parcel, so for instance, right, let me go back to my pretend parcel here. So let's say Felicia owns this parcel and Jen owns this parcel, right? So this one's Felicia's and this one's Jen. And those are right next to each other. What's between them? So this is a parcel owned by Felicia, and this is a parcel owned by Jen right next to it. What's between them? It's a boundary. And the boundary is the same for both, right? So no matter how tight I zoom in here, I should not see a gap, right? So I own, yes, it's a dimension, well, it's not dimensionless, has one dimension, which is length, right? So it has one dimension, and it's not supposed to have two dimensions, right? There's not supposed to be a gap between those two lines. So in order for our parcel map to work right, we need to make sure those lines are snapped together so that the computer knows that they are adjacent, that they share a boundary. You probably remember, and while I'm doing this, I need to get my windows up and running because I need ArcMap to be going on here. Come on. I think I'll put myself over here. That might make more sense. There we go. We'll get ArcMap up and running. So you might remember in GIS-1, one of the things that we did a lot of in GIS-1 is we used geoprocessing tools and other kinds of tools. And one way that we could select things was based on spatial relationships, right? So we could take, for instance, let's say Felicia is going to build a casino on her property, and the town requires Felicia to inform all her abutters, like the people who have land that abuts her property. If there's a slight, even if it's just like an inch gap between Felicia's property and Jen's property, and they do a little sweep using the select by location tool, Jen's property won't come up because it's not truly adjacent, right? And because it's so small, that gap is so small, you can't tell that the gap is there very often because you're looking at the whole parcel layer and you're not seeing those gaps. So not only that, if Jen's parcel overlaps Felicia's, right? Do Jen and Felicia both own part of it? No, they don't, right? No. No, they don't, right? So there's a boundary between them, and so there can't be any place where the one parcel overlaps another, because you can't, multiple people can't own the same piece of property unless they've agreed to do it, right? Well, if it's overlapping, it means there's a mistake. So it's not reflecting what's really true. Yeah, it doesn't exist. In other words, these are errors that don't reflect reality if you don't snap the lines together. So, so that's what we're going to be working through today. So an ArcGIS has this geodatabase format. Other kinds of software can use the geodatabase, but it was invented by Esri. And one of the things that geodatabases allow you to do is to actually constrain topology. So constrain what kinds of spatial relationships are allowed and not allowed in these in a layer. And there's lots of different kinds of things. So for instance, we're going to talk about parcels, but it's also relevant to municipal applications for utilities too, because utilities have, for instance, your water lines, right? Your water lines connect. And if they don't connect on your map, you're not going to be able to, for instance, see what route water might take through your lines. If your valves are not snapped on your map, they're not actually on the the junction between two pipes, then you might not be able to find all the pumps that are in a faulty line of your system, right? So you need these tools, and it makes it much easier to manage them if you can create topology rules, and then automatically find errors and then fix them. Excuse me. I ate my lunch too quickly on my way over here. I was literally like sitting, waiting to pull out into traffic, taking a couple bites, and then putting my lunch down and running out. So what we're going to do is show you how to analyze existing data So you'll have created data for problem set 2, and the last part of problem set 2 you probably noticed was this part that I hadn't shown you yet, was how to assess topology. And I have some data that has, I think it's the right one that I posted. I didn't have a chance to open it yet, but it has some messed up things in it with regard to topology. And I'm going to show you some other ways that topology gets messed up. Then we're going to fix it. Okay, so that's what we're going to do. So within the geodatabase structure is this ability to constrain these rules. And so this last definition builds on this branch of geometry definition, which is that, and it's an ArcInfo coverage, is actually a sort of between a shapefile and a geodatabase. It's about spatial relationships that are connecting or adjacent, but you can model other types too. Okay, so remember last week we talked about sticky move tolerance and snapping as a really important, really important practices to managing topology. Also, rather than actually drawing new parcels using the cut tool instead of trying to, click for each of the places whenever possible. And so that's how you maintain topological integration and avoid errors, which you want to do all the time. And so today we'll talk about how those errors can occur. We'll make some more errors so you'll see how they work. And then we'll use some tools to check and correct for them. So we'll come back to this, the topology check and correction. And I'll post this on our website. You get something to drink real quick. Okay, so what you're going to need, if you would like to follow along now, and again, as usual, it's up to you. If you want to follow now, absolutely do that. If you want to just watch me go through it and then watch the video again to do it for your problem set, that's fine too. But on this week's page, which here it is, on the week 6 page, and if you want, I can just send you a link to the week 6 page. So on the week 6 page is a link right here to download the Bar Harbor parcel data. This is, I believe, the raw data that we got from the town of Bar Harbor when we were digitizing tax maps, and we took any existing data that we received and ran it through a topology check, and there were errors, as I recall, in Bar Harbor's layer. So that's what we're going to use there. Move you down a little bit more. And so, and before we start, I do want you to be connected. Oops. I don't know why it's not connecting. I just want to make sure I'm signed in because I probably will need. Oh, it's not allowing me to sign in. Okay, well, I think it'll probably be fine. Okay, so in order to use this data, I'm going to download it. It's a zip file with a usual shape file. And I'm going to put it somewhere useful. I am on my Mac, so I apologize. It's a little more, little different from what you're used to seeing here. So I'll put this right here, and I'll call it my new folder. I'll call it Topology, Bar Harbor Topo, and I will unzip it. Okay, so there I've got my shape file. Now I'm going to go back to ArcMap and I will find it. GIS 312, and there's my topology, and there's my Bar Harbor parcels. Okay, so right now there are, I believe, there are errors in this layer that you can't see. They're not visible at all. In fact, I'll zoom around a little bit, and I think I recall some of the errors being in this area of town, and you're not necessarily seeing any gaps. There are gaps that are supposed to be there, right? So those are the roads, and you can't tell that anything's overlapping, but I happen to know there is. Now, I'm going to fiddle around with some of these. There we go. So it looks like I've got possibly, yes. So here's a topological error right here. It was invisible when I was zoomed out. So let me zoom out again. And in fact, I think that there are several problems here. So for one thing, if I use my select tool, I'll make it a little more obvious. Let me zoom in really close. So when I zoom in like this, let me get some more room here. Yeah, I really want you to go away. There we go. When I zoom in like this, you start to see that there's actually a gap, and it's almost impossible to see. But look at that. There is a gap between this parcel and this parcel that, look at how close I have to be. It's almost, it's actually larger than it is in real life, not smaller. Like that's how.
You have to do a magnifying glass to magnify it like 10 times or something.
Yeah, and how would you ever see that? The other thing is, I think right here, I think there's an overlap. So, and I'll check. So one way I can check is, nope, that's not an overlap. So there is, there's no overlap, but there is a gap between those parcels. Now, it would be a common thing, and as I said, I'm going to mess this layer up some more. So there are already apparently some topological problems in this layer, but a couple of ways that this can happen are important for you to know. So if I'm, editing, right, making my usual thing, let me edit feature start editing. And if I've forgotten to set my sticky move tolerance, which is here, I never remember where it is. Topology, where is it?
You just missed it. It was on the first tab. Sticky move.
So sticky move tolerance is currently at 0, right? And if I mistakenly, it happens all the time. If I mistakenly pick up and move an entire polygon and then go, oops, and try to put it back where it was, notice it's virtually impossible to do.
You can't just hit Control-Z?
You can, but if you forget.
Oh, if you miss it, yeah.
Yeah, trust me. Students do it. Student interns do it a lot when they're first getting started. So look, I just did the best I could, and that's as good as I could get. So that's one way that you get a topological error. And here you can see I created, it looks like I created an overlap, right? Yes. So not only did I create a gap, I also created overlaps in here. So that's a common way that that these topological errors get created. Let me close this. Another way that they get created, and I believe we will see this in the Bar Harbor layer, is this. So let's say that I have a parcel that has been subdivided, and even if I turn on snapping, which I don't think I have yet, so I'll get my snapping toolbar. Oh, snapping is on. And I want to create a new polygon, right? So this parcel is being subdivided. I can create and snap my polygon. I can even, do things all just right so it's parallel. I can trace. This is something I didn't show you guys how to do, but you can trace. Oh, I'm so awesome. I know how to do all these things, and it's so cool. And I'm gonna double click. So there it is. What's wrong with what I just did? What's bad about what I just did? I did not use the cut tool. What did I do instead? Yeah, there's still a parcel underneath, and it's not, right? So this person took this parcel and split it in half and no longer owns this part, right? So now there's two parcels, one on top of another, and I kind of have a problem. Look, notice how difficult it is just to even select them. It's actually really hard. So that's another kind of mess that you can get into. There was another thing that I was going to do. Oh yeah. So and similarly to the when you pick up and move. I'm going to turn my snapping off. When you pick up and move a vertex. So snapping is off now, and I'm going to get my editor tool, and I'm going to double click here, and I've got a vertex here, and oh, I moved it by mistake. I'm going to try and put it back, but snapping is off. So I'll do as best I can, and oh, I think I kind of am going to do it. But I've left a gap. Very, very common problem. So, so you want to avoid these errors by keeping your snapping on, by cutting parcels when possible. It's not always possible. Sometimes you have to create them. Making sure that that you, oh, right, I have notes that show you this, what I'm talking about. So use snapping, set your sticky move tolerance to be a high value so you don't mistakenly pick things up and then cut rather than create new parcels wherever possible. Okay, so I'm going to save my edits, and I'm going to stop editing with all these horrible errors in here. Now, you could spend an awful lot of time. I have to wait for it to stop freaking out. There we go. You can spend an awful lot of time looking for and correcting these kinds of errors unless you have a way to find them without, like, look at all the hundreds and hundreds of parcels that are here. How many is it? It's a lot. 3,600 separate polygons in this layer, right? So you're not going to be able to find all of these errors. And so what we want to do then is use a specialized set of tools that are in ArcGIS. You know, there are some things that other software does better than ArcGIS, but ArcGIS is by far, of the GIS software, it is by far the best option for topology. CAD software does have topological integration tools that work as well. I'm told I haven't really ever done topology like with CAD, and so very often map makers will use CAD to do it. But I've never encountered another really fully functional set of topology tools in software, GIS software other than ArcGIS. So that's what we're going to work with today. Okay, so the workflow is basically, first you need to create a file geodatabase. And there's a thing called a personal geodatabase that I don't even know if they're still, if you can still create them. But if you have an older version of ArcGIS, you might run into that. You can, yeah. I don't use personal geodatabases anymore. Their structure is not as stable, and it doesn't hold as much data. There's a couple of issues with it. So we need to create a file geodatabase, and then within that, we're going to create a feature data set. And so that's where we'll start. And so to do that, it works just like creating new anything in ArcGIS. It's in the catalog. I'll pin that. And I'll go to my Bar Harbor Topol folder, and I'll right-click and say New. Oh yeah, there it is. Personal Geodatabase, File Geodatabase. So New File Geodatabase is what I'm going to choose. And I'm going to call this Geodatabase. I'll call it Bar Harbor Parcels. And then within that, according to our workflow, we create a feature data set. And so that's basically a little can inside of our geodatabase that can hold one or more layers. The reason you use a feature data set instead of just creating a new feature class, which is a layer, the reason you use a feature data set is that it very often, not in this case, but very often, topology and other geodatabase functions like relational databases are between layers. And so you can put a bunch of layers together in a feature data set and create topological rules that operate between layers. So for instance, it's super common for if you have a utility, utility agency, and with the utility lines, you'll have a sewer line, what do you call it? A sewer line layer and a water supply line layer and a layer containing points for pumps and all these different layers. And you can say things like every sewer line has to end at a pump. It can't overshoot a pump. It can't undershoot a pump. It has to end on a pump. It has to connect to a pump. And so if you have all those layers in a data set, you can create the rules for the data set as a whole. Okay, so feature data set, and I'll call this Bar Harbor Topology. And I do want it to be our usual projection. And I will just take the, will not assign a coordinate system, I mean a vertical, because it's not relevant here. Now here you can create a tolerance, and it's the minimum distance between coordinates before they're considered equal. In other words, if you have a few little topology errors that are like a few inches apart, you can set this so that if they're that close, you disregard them as the same. You don't want to make this too large, right? It's detected that the units for our what do you call it, coordinate system is meters, and so it's saying, okay, 0.001 meters. How big is 0.001 meters?
A tenth of an inch?
Yeah, it's probably a little, it's not quite, it's smaller than a tenth of an inch. It's a tenth of a centimeter.
Oh, that's what I meant, a tenth of a centimeter. I got the wrong unit. Which
is a millimeter. So it's 1 millimeter, which is really close. We can probably, we know there's some issues in this database. So if they're within a meter, or let's say half a meter, we can probably call that, the same. If you're, and I don't want to erase too many of our, I want to keep some of our topological errors. And so maybe I'll probably use a hundredth of a meter, which is 1 centimeter, right? Z tolerance, so if you have Z values in your data, which we do not, you can set those as well. And so then it's created. So there's our topology data set. Okay, and then the next step is to import the layer to be checked into the feature data set. And that's pretty easy. Just right click on the data set and choose import. You can import one or multiple feature classes. We only have the one. There we go. And I'll just pull in the Bar Harbor parcels. Output location is already populated for you. No, I guess it's not. It's supposed to be. Where am I? GIS 312, there we go. Topology. There's my geodatabase. And then I'll open that, and it's in this feature data set. I don't know why it didn't recognize that before, but there it is. And then I can name it now. So Bar Harbor, Bar Harbor parcel topology. Okay, so, and I don't need to mess around with anything else. Geodatabase settings, barbors. There are probably barbors there. And so I'll click OK. And it usually actually does take a minute because it has to change the type. And once it's done, I can expand. Still at it, unless I need to refresh. No, I did. Okay, this is the part where Tor opens results window. No, it didn't like it. So I do need the result window to figure out what happened. Messages. Cannot acquire a lock. Why not? Okay. All right, let's try it a different way. I'm going to try and just, no, not liking that either. Definition of insanity. Bar Harbor topology.
Yeah, I was just thinking about that definition of insanity recently, because I was like 4. I was trying to pick up a head of cabbage once, and I was trying to pick it up by a leaf, and of course the leaf would peel off, so I kept picking another leaf off, and picking another leaf off. I was thinking, or I called it, gee, that's technically Einstein's definition of insanity. Guess I didn't know that when I was 4. Hopefully in GIS at least it will work.
There we go. Now I think it's might be actually working. I hope. I don't remember if it scrolled before. Do 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 do. Do 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 do. You had this issue last week, Jen? Did you have the issue of it not being able to? You had to restart your computer, huh? Yikes.
Hang on. So what's the issue? You're trying to get it to create something, or?
I'm trying to input. There we go. It did work. Okay. I'm trying to bring the copy, essentially the shapefile, into the geodatabase, and there it is.
I know. I just did the whole geodatabase a tutorial, and I didn't have any issues with it.
It's well, and you know, what I think happened is there was a schema lock. There was a lock file saved in that folder for some reason.
Ah.
Yeah. And Windows is awful about orphaning lock files, and apparently it had to think about it for a while. So one thing that's going to make my life a lot easier is if I remove the original layer, so I don't get confused about which layer I'm working with. But so now I have my topology layer. It's in my map, and then let's go over here. In the feature data set, I'm going to create a new topology. So that happens within the topology. And remember, I said you can have one layer in that feature data set that participates in the topology, or you can have 10 or some number. I don't know what it is. And so we're going to do that. And so that's in the featured data set. So it's not part of the layer, it's the data set. So I'm going to right click and choose new. And there's this new thing. Look at all these new tools we can have. There is a thing called a parcel fabric, pain in the butt. Some people do use it, but it's a little complicated. Most people don't use it. It has not really caught on. I'm just going to use the basic topology option. And the little symbol is meant to say that you can take a bunch of layers and make them work together. Again, it's adopted the cluster, the XY tolerance that I set when I imported it. And so I'll just keep that same cluster tolerance. But if you have a lot of topology errors and you know that, if they're within a meter of each other, you can just write one there, and that will get rid of a lot of your errors. I'll click next. And this is important. You need to select the feature classes that will participate. Notice if you have 10 layers and you only want 3 to participate in it, you can. So of course I need that one. And I'll click next. And there's each feature class in a topology must have a rank assigned to it to control how much the features will move when the topology is validated. The higher the rank, the less the features will move. There's only one layer, and I'm not actually, so this is a relatively new function. Let's see, the higher the rank, the less the features will move. Well, we don't really want it moving features, so we'll just give it a 1. Okay, now we have to create rules for the topology. And rules are what you're telling ArcGIS, you're saying, yo, ArcMap, if anything overlaps, or if there are gaps between polygons, I want you to tell me. So you have to add rules. So I'm going to click here and say add rules. And for the feature class Bar Harbor topology, must not have gaps. Right? I only have the one layer, so it's not giving me any other layer I can work with. So it must not have gaps, and I'll click OK. I'm going to add another rule, and that is must not overlap. And if you choose the same layer in both, it's saying one polygon from Bar Harbor topology can't overlap with another polygon from Bar Harbor topology. It's not valid. Why not? Must not overlap. Oh, must not overlap. Okay, must not overlap. That's what we want. Nope, apparently it's must not overlap is with itself, but overlap with would be with another layer. There we go. And I think for this, that's where we'll leave it. But I do want to mention that for line data, rules often are must not have dangles. And all topologies have that automatic rule, which is that they can't be larger than the tolerance. So if you are going to have a little tiny polygon that's only a meter wide, that's larger. That could be smaller than your tolerance, in which case you'll get an error for that. Okay, and so those are my rules for my feature class, and I'll click next. And here's a summary, and I just click finish, and it generates the topology. And it's analyzing all of the polygons in this layer. to see which ones break the rule. And it will look alarming, and it'll say, oh, a new topology has been created. Would you like to validate it now? And I'll say yes. Okay, and then, so now I have this new item here in my feature data set right here, a new topology, and I can bring that in to my map. And in fact, it'll add the parcel layer again into my map, so I can remove one of them. And so everything you see here that's red is ostensibly an error. Some are really errors and some are not. And so I'll explain how that'll work. But anything that's red, and here you can see there is actually quite a lot of, yes, most are lines, errors. No, there are no lines. These are all polygons.
Then how come most of the there's a red outlines around everything, and there's like one red area in the center, and then a few other red spots. Most of them are like light red lines, like the line error.
Yep, you'll that all will be explained.
Okay.
Yep. So, oh, I see, line errors. These are yes. So these are edge errors. I see what you're talking about, line errors. Is that topology document you keep opening available? Yeah, I haven't posted it yet. Do you want me to post it right now, Shelley? I can do that. So, yep, let me do that right this sec. And I will. Oh, wrong. No. Oh, wait. There's our class. Okay. I'm confusing myself. Let's see. Click here to download the topology definition and workflow document. Get the actual where to put it. This is what I hadn't done yet, is I hadn't put it in my folder yet for you. There we go. Move here. And we'll share. Copy link. We'll put that. All right, I'll check and make sure it's there. And it should be. There it is. So you can click that now and it will appear for you. No problem. All right. So here we are. We're going to start an editing session. We're going to go through, and you'll be amazed at how efficient this process can be. The process, the topology tools are designed to make it much easier to find and correct topology errors, so you can do hundreds and hundreds of them very, very quickly. So I will do that now. So there are area errors, there are line errors, and there are point errors. Line errors are, I don't even know if we would even have any point errors in this, but the line errors are boundary errors in the case of polygons, and area errors are overlap. I didn't understand that you were looking at the table of contents, Felicia, but now I do. So there is a toolbar called Topology, believe it or not. There it is. So I'm going to get that toolbar because I'm going to need that maybe. And I'm going to start editing my layer. So I'm going to right click and choose Edit Feature, Start Editing. And, and notice that once I started editing, my topology tools became available, and there's a really, really, really helpful thing called the error inspector. So I'm going to click that. That's the last button right there. And I can, I'll zoom to the whole layer here, and I'll say search now. And when I do that, put myself back over here. When I do that, I can see I have 345 errors, which seems like a huge amount. But you'll see very quickly that most of them we'll be able to get rid of. And watch what I can have, what I can do is I can click on one of the rows in this list of errors, right? So there's a whole bunch of these. I can right click and get a bunch of things that I can do, like zoom to that error. And I can tell that if I can tell that it's what is known as an exception. So this is telling me about a gap, but it's a gap that's actually roads, right? And the roads are blank between the parcels because we erased them. That's how we created it. So this is actually an exception. I don't need to keep it. So I'm going to right click on it and I'm going to choose mark as exception. And you'll find that most of these errors will be exceptions. And there I can see, I can zoom to it. I can, zoom right in and see that that's an exception. And in fact, I believe if you double click, does that work? No, I guess you have to right click and choose zoom to. Right, so you can do this pretty quick. And in fact, zoom to, there's that. I can right click and I believe I can just, used to be, I think I programmed it so that when I typed in E, it marked it as an exception. Zoom to, there's another exception. And I believe if I go to the next one, yep. Yep. And I can keep doing this. So notice I've got these 4 are all exceptions. I can zoom to and see them all at once. And I can mark them together as exceptions. And so I've taken care of 4 right off the bat. There's an island there. Of course, I can mark that as an exception. There I can see that's an exception. Now here I can't see it, so I'm going to zoom to it. Aha! So this is the first actual error that I have. And it says must not have gaps. So that's the rule that it's breaking. I might be able to see, I can just barely see that, that there is a gap right there. And so I have a couple of options for how to fix it. I also can see that there's another error involved, right? So, and I can tell which error it is by clicking this search now, and it will search just the visible area. See, visible extent only. So I'll click search now. So these 2 errors are both involved in this one parcel. So I'm going to fix that. And the distances here are very small. So it's 1 to 37.25. So I'm zoomed in really far. You don't generally end up having to measure them, but I want to measure them to show you how small these errors can be. So it's about 1/2 meter is the error in this dimension, and in this dimension, it's oh wait, no, it's not 1/2 meter. It's it's 6 centimeters is the error here, and it's 9 centimeters here, right? So so it's a really, really tiny error, but fortunately it's super easy to fix. So the error is in this parcel. Let me zoom to it so you can see it. Zoom to selected feature. So it's that parcel, right? And so that's where the error is. And I can I'll even turn this off so you can see. If I double click it, I'll get its individual vertices, or that's the plural of vertex. I have a couple ways I can handle this. I can remove, it probably makes sense actually to remove one of the vertices. And in fact, I got my editor, my vertex editor up there. You can use the tools or just right click on the vertex. So I'm going to delete this vertex by right clicking it and choose delete. And I'm going to pick up this vertex. My snapping is on still. And so I'm going to snap that vertex here. And now I can, let's see, I want to move back out. I'm going to zoom out a bit here. There we go. And so I could see if I wanted to work on this parcel some more, I could see that there were other topology errors with that parcel. Turn this on, let's say search now, and you can you can validate topology in the current extent, right? So it got rid of, once you can't really see that, but it's a little button on the topology toolbar that has a little checkbox right there. So when I click validate, it showed me that there's another couple, 3, it looks like, errors there. So I'm going to zoom in here, and I'll search now. Okay, so it has 2 overlaps. Looks like it's the same parcel. Now, I can, let's see. Yeah. So I can do this process called merge, and to see it, let me zoom it in a little closer. So I can do this process called merge, which can be super handy, right? The distances that we're talking about, there's this overlap. It doesn't really matter if you move this chunk of 3 inches to one side or the other, so you can just pick one. And so I'm going to merge this this sliver. It's called a sliver. I'm going to merge this sliver with one of the polygons. I think I can't tell which one is straighter. I think the top one is straighter, so I'll merge it with the one on the bottom. So here's what I'm going to do. So that's the one I'm talking about. I'm going to choose merge, and watch what I can do. If I click on here, it flashes which polygon is going to get that sliver in the end. I want the bottom polygon to get the sliver. And I'm going to click OK. And look at that. It fixed it. Not only that, but it reanalyzed and removed the error. I can do the same thing, the other one. I want to make it a straight line, so I want to make sure it's it does the same, goes the same direction. I'm going to right click and choose merge, and I'll see which one it is. So that's the bottom, that's the top, and I want it to merge with the bottom one. So I'll click OK, and the problem is gone. There we go. So let me zoom out. There's another error with this particular layer, a particular parcel. So I'll get these and search now. Must not have gaps. So that's a gap. I'll zoom in here and see what that's all about. And notice that when I right click on a gap error, there's no merge possibility because there's no extra polygon. And so you can double click here and here. And this is a very good classic type of error. So notice that it snapped here and it snapped here, but there's a vertex in between them that isn't snapped. And I can prove it to you by turning this off and zooming in. There, so you can see that's not snapped. All I have to do is get rid of that vertex and my problem will be solved. So I'll just right click and choose delete vertex. And zoom back over here. I can validate in this area and problem is gone. This is some other kind of error. Search now. I'm going to zoom out so I can see the whole thing, get a sense of it. So it is an overlap. So it's possible to fix with a merge. And looks like a very small overlap in one end of a very long border. So right click zoom to. And yep, actually in this case too, there's an extra vertex. See that? So it's a straight line between these two vertices on this parcel, but on this one, there's this extra vertex. Now I'm remembering this is how we got Bar Harbor's data. They had these errors in their data when they sent it to us. I didn't create this. So I'm going to just delete that vertex. I'll validate again and search now. And all I have is this one. So let me zoom to that. That's going to be an exception. And let me zoom to the whole thing and see how many I've eliminated already. So search now. I'm down to 329. So pretty soon I'm going to go into production mode here. So I'm going down and selecting everything I know is an exception. If I'm not sure, I'll zoom to it. There's an error. And so this is a gap. Yep, and okay, so there's a gap. And it looks like just a matter of snapping. Yep. So notice, let me zoom in here so you can see it. Notice that this vertex is not snapped with that one. So all I have to do is pick one of them and snap it to the other, just like that. Notice how it says Bar Harbor Topology Vertex. When it's snapped, I let go and validate again, and the problem is solved. So let me go back to here and search now. Zoom to, here's another, oh boy, this one looks like a doozy. Oh, yes, yes, yes. Okay, so this one is created. Oh man, this is so bad. So this one was created when they created this round
like a park or something.
It's a cul-de-sac.
Ah.
Yeah, and so they use the cut tool, but in managing the data somehow they did not manage their XY tolerances very well. How many is this? Search now. It's 58 errors.
Oh my.
Yeah. So as you can see, avoiding this is better if you avoid it. And so it's relatively easy to fix just by snapping things to each other. But you end up having to validate over and over again to sort of see them. Delete vertex. Can you imagine trying to do this with there we go. Okay, validate. Thank you. Trying to do this without these tools, it's just hell. delete vertex. This also might, it's possible that this was the result of somebody having picked up and moved it by mistake. That might actually be what happened. They picked it up and moved it by mistake instead of Control Z or whatever, or just don't save it. And so you can do that any number of times. There we go. And hopefully you're getting the idea. And it gets to be super quick, actually. You get to be very fast at it, so that it doesn't really take very much time. It's just a matter of a second or two in every case. And notice I'm feeling along the edges in some cases to find the vertices. And I'm validating my validating to make sure that I've actually dealt with the problem. Delete that vertex, I think. Come on. Oh, you have to go back to being selected and not vertexes. And looks like I still have, oh, I have an extra vertex there. And so on. Oops. And here's a situation where adding a vertex will make sense. So I'm going to right click on the line and say insert vertex. And then I have something to snap to that little corner right there. And I will check again to make sure I've taken care of the issues. And I have. Slowly getting there. Extra vertices, delete vertex, delete vertex. Often it's the problem is too many vertices. That's a super common problem. So whenever you're digitizing, that's why, remember I said make long cuts all at once. That's one of the reasons why, is that if you're just going click, click, click along what's supposed to be a straight line, you could be adding all kinds of fun for yourself later. And fun, fun, fun. Yes, well, and XY tolerance is only one of the things that leads to this. Pay attention to XY tolerance, pay attention to snapping. Probably snapping is the most important of these issues, and the sticky move tolerance. Yep. Slowly getting there. I'm gonna move that over, and I'm gonna, let's see, was the issue too big snapping or too small? So snapping tolerance, is really depends. So you want your the tolerance for when you're snapping, it determines how close your cursor needs to be to whatever it is that you're snapping to. And if your tolerance is too small, then you have to get super close and be really precise in order to snap. And if it's too big, you'll never get close. You'll get sloppy, basically. Okay, I'm almost, I don't know. I have no idea how far I am from being done with this. Yep. And so you're getting the idea, and you're getting the idea that you really do want to pay attention to these things and not ignore them. They do mean things. So I got an extra vertex, and maybe this one needs to get, yep, snapped. So, no, did I not fix? Guess I didn't. I'm going to zoom in here. I can't see. There we go. Delete that vertex. Okay. Now you're almost happy. There's that vertex. Okay, let's see. Let me zoom out to see the whole thing. Oh, it looks like I have a couple more. Oh my gosh. Don't you wish you got paid per vertex? Yeah, that would be great. $1 a vertex. Anyhow, there we go. So I was able to deal with some of them, with a bunch of them. And I want to be careful here. I might, I don't think I set my sticky move tolerance. I'm going to set it to 500. I don't want to mistakenly move something here after all this dithering. There we go. And snap this one. And oops. Oops, I'm doing the wrong thing. There we go. This is a great thing to pay interns to do, I've discovered. Because it does not require a lot of, lots of training, so it's easy to teach somebody pretty quickly how to do it, but it is time consuming. I don't necessarily need you to watch me fix all of these, but hopefully you're getting.
What do you plan to do after you get these fixed? Was there something you needed to run after everything was fixed and you couldn't leave anything unfixed?
I'm not sure what you're asking.
I guess that's big. I wonder if there's a reason you need to fix every single one besides for showing.
Oh, well, I'm mostly just showing, and I'll stop soon. I just wanted
That's
to.
fine. I'm just trying to understand what's going on.
Yeah. So there we go. So okay, so we can even pretend that I've done it all, because I am starting to get bored. I'm so close though. All right. And so anyway, let me go to the whole thing. So I'm down to 278. Let's not have gaps, so that looks like an exception. I can tell from here. Let's zoom here. Oh, that's an interesting gap. The heck is going on there?
Accidental line, perhaps.
I don't know what that is. Let's see. Let's turn that off. Check it. Ah, okay. I think it's a leftover hunk of something, you know, topologized. Is it 520? Oh my gosh. We gotta stop here soon. Okay, so now you get the idea, and you can get to the end of this process. This is an unusually large number of topology errors, but these tools streamline it and make it much easier. Once it's done, you can save your edits. In fact, I should save, right? Save edits, stop editing. Once it's done and you've cleared, either marked as exceptions or cleared all the topology, then you don't need to leave the layer in a geodatabase. It's no longer necessary. And our practice at UMM is to not leave them in geodatabases, because we are typically not, we're often working with people who have other kinds of software and may not, have that topology as an option. So have the geodatabase as an option. So that's how you check topology. And if you look at problem set 2, which I think is linked right here from the page. If you look at problem set 2, that's what I want you to do, is do a topology check, correct any overlaps or gaps, and the edits are saved in the parcel layer, so they're saved in this layer, right? And so I can go data, export data, and save it as a new shapefile. You don't, and this is not required for problem set 2 that you save it as a new shapefile, but you can do that. Data, export data, and I can put it in, my folder here, and I can change this output to a shapefile, and I can call it Arbor Topo, or Topol is usually what I use, and save it like that. And that now has all the changes that I've made are saved there as a shapefile. So that's what when we provide data to other, to clients, we use shapefiles and not geodatabases, because not every software can read them. All right, so you guys now know what you need to know. I have to run and teach another class. And Jen, are you in the lab? Or are you